All right, you guys, let's take a look at this question, which I believe is question number 13. Okay. So I'm going to do it by definition, the way that you should know if you're going to proceed on into trig or calculus. And then I'm going to talk about the quick way if you're given a specific case of a polynomial. Okay. So the test for whether it's going to be even, odd, or neither. So for even, when you plug in a negative x for the x, you should just get the original equation f of x back. For odd, when you plug in a negative x for x, you're not going to get the original f of x back. You're going to get the opposite of it. So in other words, all the signs should be changed. Okay. So this is what you want to know, what you want to take out of this section. So let's go in here and test this. So I'm going to substitute in a negative x for the x in this equation up here. Okay. All right. So it's going to say negative x to the 9th. Well, if you think about having 9 negatives, right? Anytime it's odd, you're going to have a negative left over, right? Let me do a smaller case of like 5 of them. 1, 2, 3, 4, 5. Well, if it's an odd number, then these 4 are going to pair up and have buddies. And the negative times a negative equals a positive. A negative times a negative over here equals a positive. But you'll always have this one leftover negative. And so that's why, well, we know a positive times a positive is positive. But now if you multiply that by a negative, the answer ends up being a negative in that. So as long as it's odd, you'll always have one of those leftovers. You won't be able to form pairs, which means it should always stay negative. So this is going to be negative x to the 9th. Okay. All right, so if we look, that does not match the original, right? Okay. But it is opposite the original. So it's not the original f of x. It's negative the original f of x, right? Okay. Or in other words, you want to think it just changed the sign on this guy. Okay, so I probably shouldn't have put this in this column because I should have put this over here, huh? So it turns out that this is an odd function because when we plugged in negative x, we got negative f of x out. If we had plugged it in and we got just an x to the 9th without a negative in front of it, then that would have been even because that would have matched the original exactly. So both of these start the same. Notice both of them start with us plugging in a negative x. Plug in a negative x. But do I get the original out? Do I get opposite the original out? Okay. And then if I don't get either one of those cases, then of course it's going to be the neither. Okay. But in this case, because we did get the opposite of the x to the 9th up here in the upper corner, we're going to go ahead and say that this is an odd function. Okay. Now, if in the event that you're given a polynomial, which we are, okay, polynomial is just a bunch of like coefficients with x's to some non-negative power. Something like this is like a polynomial. Okay. If you're given a polynomial where all the exponents are odd or all the exponents are even, right? Then that would be an odd function and an even function. So let me give you an example. This right here would be considered odd because all of its exponents are odd. If I have something like x squared minus 7, that would be considered even because there's an x to the 0 behind every single constant. X to the 0, anything to the 0 is just 1. So you can always put an x to the 0 behind something, okay? So all of our exponents are even. Okay, it's going to be an even function. Well, if we use that up here, we could have gotten this in like a second. We could have been like 9 is odd. Boom, this is going to be an odd function. Now, why do we teach these definitions of even and odd? Because in the future, you're going to have functions like this, where they're not polynomials, or even a function like this. And in these functions, it has nothing to do with the exponent. By the way, the exponent here is 1, but this turns out to be even, right? And this one right here is odd, while this one is even, okay? So we have to have this definition, so it will apply to all functions. But in the event that you're given a polynomial, you can just look at the exponent and be like, okay, are they all even or are they all odd? Now, if you have a mixture, like let's say you have 3x to the 7th plus 9x squared. Well, one's odd and one's even. So this would be the neither case, okay? But these definitions are really important if you plan on moving on, especially in trig, we do a lot of proofs with them. And sometimes in calculus, they're good to know too. So if you plan on moving on, definitely know these. And in my class, you will have to know it at least for the test. You can empty it out later, okay? All right, you guys, thanks for joining me on this one. Take care.